let's go ahead and evaluate this double integral over this general region D. So as you can see, the double integral itself is going to be pretty simple. The function is just x. And so, sort of as usual, the challenge here is to determine your limits of integration. And so here, one variable should end up being bounded by two constants. And then the other variable should be bounded by curves. So when we have a rectangular region, both variables are bounded by constants. But when we have a general region that involves a curve, one will be bounded by constants and the other is going to be bounded by curves. Now, usually we can decide this, at least I try to decide just by looking at the curves I've been given. But here they're so simple that I bet we can go either way. So we have y equal to x. And so it's easy to have y isolated and it's easy to have x isolated. In fact, it's already done for us. And then y equals 0 and x equal to 1 are just straight lines, right? They're constant themselves. And so that should be pretty easy to use either order of integration. And so I think I'll show you how to use either order. But now the first thing that we'll do is get a sketch of our region D. I always sketch the region D because that'll make finding our limits of integration much easier. And I always start by finding out where my curves intersect each other, and that's going to help us sketch. And I'm actually going to start my sketch here because I'm going to draw in these straight lines. Here, the sketch is a little bit easier than usual because I have y equals 0 and x equals 1, and those are going to be pretty easy to draw in. So let's see. I'll let y equals 0 be green, x equals 1 be blue, and I'll let y equals x be red. When y is equal to 0, that just means we're on the x-axis, and so I'm going to be here. This is y equal to 0. Go ahead. That wasn't good. Go ahead and make this whole line green, the whole x-axis green here. Okay. And then my blue is x equal to 1. So let's make this x equal to 1. And I'll have this line here. I'm cheating a little bit because I already kind of know what it looks like by keeping this all in the positive. But of course, the line x equals 1 extends all the way down as well. And the line y equals 0 extends to the left, but I'm just going to keep it this way. Okay, so here's just the start of my sketch. But now I want to see where my line y equals x is going to intersect both of these lines. So if, I'll start with the first one. If y is equal to 0, then x would also be equal to 0 because x is equal to y. And so I do have a point at 0, 0. That's one of my intersection points, 0, 0. So that takes care of y equal to 0. Now I'll move on to if x is equal to 1. And they've made this nice and easy for us. If x is equal to 1, we know y is equal to x, and so y is also equal to 1. Okay? So I get a point at 1, 1. Now I can very easily draw in my line y equal to x. Now notice this could also be written as it's the same thing, but x equal to y. Now, as usual, our sketch should give us all the information we need to know to get our limits of integration. So let's go ahead and get those. Oh, this is my region D. I always want to label it and I forget. So there's my region D, that triangle. So I'm going to show you two different options, actually. One where x is bounded by constants, and the other where y is bounded by constants. So I'm going to start with x. I'm going to let x be the one that's bounded by just constant values. So how far do we go to the left for our x values and how far do we go to the right with our x values? The furthest to the left we ever go is here at 0. And the furthest to the right we ever get is here at x equal to 1. Okay. Now y we're going to allow to be bounded by our curves. Now at the lowest point or at our bottom curve, actually let me draw on a line here. Use black, I guess. So I'm looking at y, so up and down. So my bottom curve is the green one. It's y equal to 0. So I actually do get a constant as my lower bound, but that's because y equals 0 is actually one of our curves. Just coincidentally, our curve is a straight line. And so that's our bottom curve is the green one. And then what's my top curve? Well, it's this red one. It's y equal to x. And so it gets bounded on top by x. So that's one option. That's actually the one I think I'm going to integrate using because I just kind of like it. But we could also bound y by constants if we wanted to. So do the opposite. Y, the lowest value of y is 0, and the highest value of y is 1. Right, the lowest y ever is right here at the bottom at 0, and the highest it ever gets is here at 1. I'm going to bound x by my curves. Now I'm thinking left to right. So now my line is going left to right. My leftmost curve is actually y equal to x, or x equal to y. And my rightmost curve is x equal to 1. So these should both work. So whichever one you happen to pick would be fine. But I'm going to use this one. Why? I don't know. I just like it. So that's what I'm going to use. Let's go ahead and set ourselves up. So we are integrating over our region D, x dA. I'll be very careful when we set up our double integral. We always want our constants on the outside integral. On the inner integral, we have our curves. And then we have to be careful again, because we now need to label our dx dy or dy dx. We need to make sure we do this properly. So I'm going to think of this as my inner integral, and this one is my outside integral. The inner integral here has limits of integration 0 to x, and that was my bounds on y, so this is dy. My outer integral has the limits of integration 0 to 1, and those are my bounds on x, and so this outside is dx. Okay, and now we're ready to just go ahead and integrate it. Looks like it won't be too bad. So I like to go ahead and solve my inner integral first. And then I kind of plug it back into the outer integral. So I'm integrating x with respect to y. So I just get x, y. Because we're thinking of x as a constant. And so we just tack on this y. And we're going from 0 to x. Now we have to be very careful. We are integrating with respect to y. And so these limits of integration are my y values. So at this point, we're not plugging anything in for x. X is just hanging around, right? We keep the x. And when I evaluate at my upper limit, x goes in for y. And when I evaluate at my lower limit, 0 goes in for y. I love having one of my limits of integration to be 0, because I just like it when things disappear. And so when we go ahead and simplify this, we just end up with x squared. This is my inner integral. Let's put a little bubble around it. I'm not quite done. So this is going to go in for where I had these brackets. I evaluated this whole inner integral. So now I have 0 to 1 x squared dx. But as usual, now that we've completed the inner integral, we just have a normal integral to deal with. It just has one variable, x. So it should be pretty familiar to us. And so we have x cubed over 3 from 0 to 1. And again, we could label this as x and x because these are x values. But I think it's pretty obvious at this point, but doesn't hurt. And so when I evaluate at my upper limit, I get 1/3. And when I evaluate at my lower limit, I get 0. See how nice having 0 is? And so I just get 1/3. And there we have it.